We're now going to convert multiple digit inputs to numbers. In the previous example, we had just used a single digit input to convert to the blink rate. And this is that sketch, right? We saw that it's already uploaded. We saw that if we just typed in something like the number 4, right, we use the 4 then to multiply by 100 to get a blink rate of 400. We were doing that here in loop by checking when there was data available. We read it in. We verified that we had a digit before we updated the blink rate. We then subtracted the ASCII character value of 48 or 0 from read byte to convert that to an integer value, right? To convert the ASCII 4 to the number 4, right? And when we multiply blink rate by 100. Let's take a look at what would happen if we wanted to actually then have multiple digit input. So part 3, illustrate, then we're going to illustrate how to how to convert a numeric string to numeric character string to an integer value, right? All right, so let's still start off with our default blink rate of 100. We're only going to read information from the serial port when it's available. But now we're going to think, we want to be able to read numbers, right? So let's put in some examples here. Example, read the character string 256 and convert it to the number or the integer, right? Integer value 200. 256. Right. Right. Similarly, right, we want to then be able to convert values. We want to read the character string 94 and convert it to the integer, right, value 94, right? Or maybe longer strings, maybe 4-digit strings. All right, so we want to take a look at the fact of 256. 256 is equal to 2 times 100 plus 5 times 10 plus 6, right? Which we could also write as 2 times 10 times 10 plus 5 times 10 plus 6 times 1. And if you look at those as powers of 10, that's equal to 2 times 10 squared plus 5 times 10 to the first plus 6 times 10 to the 0, and the positional notation that we use for numbers. We're going to make use of this idea here. What we want to do is we're going to create some other variable. All right, and we're going to say int temp value, and we're going to set temp value. Actually, let's just create a sum and set sum equal to 0. All right, now when we read in new information, If it's a digit, what we're going to do is we're not going to update the blink rate right away. Let's just go ahead and accumulate things in sum. Let's not even worry about the blink rate at this point. We're just going to say sum is equal to sum plus read byte minus that 48 or that character 0. So if we just do this much, and let's print out sum here. So let's upload this. All right. So if I typed 256, I don't quite get what I want, right? Because here I've got sum plus read byte gives me 2. The next time through here, the next time through when I'm reading this, I'm going to have sum already had 2 in it. I'm going to get the number 5. I'm going to add 5 to it, and then I'm going to end up getting the number 6. So I'm not doing the multiplications by 10, right? Let's take a look at what happens if we say sum is equal to sum times 10, then plus this read byte minus 0, right? I don't need to have the parentheses around these. Right, order of operations is multiplication would come first. Here, this is okay. This would still work without them, but I just want to go ahead and put this on for emphasis. All right, let's upload that. And let's see what happens if we type in 256. That's what we want. So the first thing it does is it read in that 2 that we typed. And so sum was equal to 0. 0 times 10 was 0. And then we added the read byte of 50 minus the 48 gave us the 2. Sum was equal to 2. We printed that out. When this looped back around, right, inside this loop function here, then we read it in the next byte. And that next byte then, right, was a digit. That was the number 5. We had 2 in sum, so 2 times 10 was 20. Plus then 54 minus 48 gave us the 5. We got our sum of 25. We printed that out. We looped back around. The next character, the 6, was available to read. Notice we had a 25 in sum, so 25 times 10 was 250. Plus read byte, the 6 then minus the 0. So this 54 minus the 48 then gave us the 6. Right, and we got our number of 256. Right. Now, if I were to type in another number, say our 94, our sum won't be what we want it to because we have to go back and reinitialize it. But what we want to do is once we get something, once we get an end of transmission, we want to then update the blink rate. And so what we're going to do is we're going to say here, use the new line character to signal end of transmission or end of data. Right? Meaning I'm going to now start appending a new line character to this. And here, let's say while serial.available is greater than 0. So while there's something to be read, let's read it in. If it's a digit, let's go ahead and update our sum. Else, if read byte equals, well, our new line character is a 10. We've seen that before, so we can say 10, or we can say this. Then we want to update the blink rate. Now we can say blink rate is equal to sum. We can now reset sum back equal to 0. And let's go ahead and print out some information. Serial.print updating blink rate to, right? And let's print out the blink rate. All right, let's see if that's what we want now. All right, so I changed this to while because we have multiple digits. We might as well just go ahead and read in all the digits. All right, we're going to take the good digits, turn them into numbers. We'll come up with a sum. This will signify the end of that string of digits. All right, when we get that, we'll go ahead and update the blink rate. And so let's upload that. So let's try our 256, hit the enter key. All right, so we got the same as before. Sum came up to 256. Notice then the last character that was sent, because I had to change this to new line. If you haven't changed that to new line, it won't be appending anything, right? This wouldn't work with no line ending. Let me put it back. Well, I'll show you that in a second. All right, so now I update the blink rate because the new line was there to 256. Now what happens if I type in my 94? Right? Because we had then set sum, we had initialized that back to 0. What that did was it accumulated the new string of numbers into a 94 and then updated the blink rate to 94. Similarly, I could type in a longer string. I could type in 1, 2, 3, 4, 5, but notice that's going to give me a very long blink rate now. Now this has to be on for about 12.345 seconds. And then off for about 12.345 seconds, meaning this function is going to be in that delay mode for a while. It will take a while before it processes any information I might type here. I'm going to have to wait about 25 seconds, or depending on where that was. Fortunately, that was somewhere in the middle. It was faster than the 25 seconds. I updated the blink rate. Right. Now, let's just go ahead and actually, I'm going to restart this. I'm going to get rid of that new line. So if you forget to send this, right, if you have this, if you forget to change that and you have no line ending on there, if you type your 256 and hit enter, right, your program is just literally sitting there because you haven't appended that new line ending. I shouldn't say it's sitting there. Right in the 256, but notice it's not updating your blink rate. It's running the default blink rate at this point. Right, so if you see those changes not happening, right, you need to make sure you're appending that. Similarly, if I appended the carriage return to this, the carriage return is something completely different. Right, now I type my 94, I didn't get to reset things. Let me actually restart this. And notice when it restarts in the mode where I last left it. So now it's restarted with carriage return. So 256, right, it's still not working. So make sure then everything's set up right. Make sure that if we're using new line as the termination of the string, that's turned on, so it will append that. All right, if I do my 94, that works. If I do 345, that works as well. All right, so what we've seen here then is we can take these individual characters, we can combine them into a value simply by reading the first one, storing it in a sum that's been initialized to 0, and then as we loop through this, multiplying what's in sum by powers of 10, adding on the new digit to form then that integer string. Right. We then had to have something to signify the end of termination in order to update the blink rate. We updated the blink rate when we read in this new line character. Right. You could have chosen one of these other methods. I just happened to use the new line character. I wanted to show you when that comes in handy. So that's how we can do this then manually, right? And that works for us. Right. Similarly, I want to show you that Arduino has a function called parseint. So here in the serial library, there's one called parseint. You make that print a little bigger. All right. So what parseint does is it looks for the next valid integer in the incoming serial string. In particular, initial characters that are not digits or a minus sign are skipped. We weren't working with minus signs. We would have skipped over characters. Actually, our function skips over any character that's not a digit, right? It just keeps taking in digits until it reads the new line character. Parsing stops when no characters have been read for a configurable timeout value, right? Or a non-digit is read. If no valid digits were read when the timeout occurs, 0 is returned. Right, so you call this as serial.parseint. There's another way to call it as well. We're just going to concentrate on serial.parseint. Skip chars used to indicate over certain chars in there. This is going to return something of data type long. Now the thing is parseint, right, can take a while. Notice here, if no valid digits were read when the timeout occurs, then it will return 0. So this takes a certain amount of time. See serial.set timeout. Right, so it's a timeout, then fixes the maximum milliseconds to wait for serial data. It defaults to 1 second. So it can take 1 second if nothing's happening, knowing that your program hangs up there if you use serial.parseint. All right, so I'm going to close this. Had a couple instances open. Let's pop open our sketch. Right, here was our sketch then. Where we were using read byte to form the string. I'm just going to write a new sketch now using parseint. All right. So serial.begin. In this case, then we want to set up the baud rate to 9600. Let's open that last sketch so we don't have to rewrite sections of it. Let's go ahead and get, actually, I probably just should have done a save as for that. All right, here's what I want to do. I want to keep the blink right. All right, we're going to use serial.parseint to convert numeric strings to integer values. Right. Not going to need now. All right, so that returns, I'm not going to need some. I'm just going to call this I value. Right. We're still going to blink this. We're still going to have a default blink rate of 100. Here, I still only want to read when serial information is available. But instead of while, I'll just call this if. And now I'll say I value. All right, I want to assign to that. I'm going to call serial.parseint. I don't need all this is digit stuff here anymore. Let's just go ahead and print out then our information that is in I value. All right, so we're calling blank. We're just going to go ahead and print out what's in I value when we get something. All right, say this is serial.parseint example. Let's upload it. Blank. It must be. had an extra curly brace. All right. All right. So I'm not printing out the blank value, right? We're using our default of 100. Now let's just go ahead and type in our 256. Hit the enter key. We get 256. Now, why did I get the I value? Well, I got the I value of 0 because I had this new line turned on. So what this did was it then wrote the 256, .parseint read that in, and then it read in the ASCII value for the new line and said, well, that's not a numeric digit, so I'm going to turn that to 0. So now if I turn this to new line ending, so no line ending, 256, hit the enter key. Right, now I just get the 256 and not that I value, because we have to remember then, right, when this new line was turned on, we did the 256, hit the enter key, we transmitted the 256 plus the new line character. That new line character then gave us this result here of I value. But what we want to do is we want to turn on the no line ending. And then what we could do in here is we could then update the blink rate. So we could now say blink rate is equal to the I value, which is less cumbersome than what we just did with the other method. But now we understand how the other method works. If you're working with a microcontroller that doesn't have a nice parseInt function, right, you know how to write that. And right, once we do that, we could also print out the new blink rate, serial.print. And notice I'm only printing it out when I update it. And I don't want to see it too many other times. And actually, if we want to trust what parseInt returns to us, we could just assign that directly to blink rate, couldn't we? Here's my 256, right? Then we update that. My 94, we update that, right? So the thing to remember then is parseInt, if there's nothing that can read, then if I type try, hit the enter key, well, TRY wasn't valid. If I just type a T, hit the enter key, right, it's going to return a 0. All right, if I type 94 and then a T, notice we're going to get the 94, then it's going to get the T, and then it's going to read that T in and turn that to 0 for the blink rate. All right, so that's how it's going to handle non-numeric data for us. All right, so the parseInt function then will actually then turn that string into an integer value. Same way, if I type a couple blank spaces and then hit 475, hit the enter key, right, it skips over then those leading blank spaces and we get the 475. If I type 475 space space and hit the enter key, well, it reads the 475. Now, then it reads the space and gives me a 0 because it doesn't understand what to do with that. Notice the leading white space it said it skipped over, so space 475, hit the enter key, I get 475. All right, but space 475 space enter key skips over leading white space, I get the 475, but then the trailing space it reads in and now I get a 0 from it. Right? Normally you're not going to be typing things in from the keyboard into a hardware program. You'd usually be transmitting them from some other source, but you've got to be aware of how parseInt works. Right? Test it to make sure that when you transmit data from some other program, you're transmitting it in a way that this will correctly work. And now you have an idea of how to use the parseInt function. Right. The next topic after this will be Arduino to processing.